Hello everyone. In this video we are going to talk about loops, which is basically performing a task or some task that you have to keep doing, repetitive tasks. There are two major loops in Python, for loop and while loop, just like MATLAB, and there is no do while here. And the idea of for loop and while loop is the same as any other programming language. For loop is when you know how many times you are going to repeat something. While loop is you keep doing it until some condition is satisfied and you don't know exactly when that would happen. So let's say here, for example, I have this vector and I want to go ahead and print every other number in this vector, right? So one of the things I can do is I can use a for loop and say for I in range 0 to length of the vector with step of 2. So what does it mean? It means go from 0 to length of vector 2, which means every other one. Go ahead and print what? Print that vec I. Now what does it do? As you all know, here it starts at 1, jumps to 5, jumps to 9, jumps to 18, and goes to what? 26, and that's it. Remember this range, right? Remember this range operator. It will never give you what? The final number, if you remember, right? So if I add one more number, let's say 45, would I get that 45 here, right? So you can guess ahead of time that the answer is, well, let's take a look here. So length of vector is how much? You see, I did. Some might say, well, wasn't it supposed not to give me that? Well, that's the trick here. The trick is when I say 0 to length of vector, this total length is the length of the vector plus 1. So really, I should say length minus 1 because that's the size of the vector, right? Here, what is the length of this vector? If you look at the numbers, it's what? It's 11. So I'm saying from 0 to 11, which includes 12 entities, but since the last one is always not included, then it's going to be 11 entities. So yes, it does include the last one. If I said length minus 1, then no, the answer is I'm not going to get it. So you see, that is a beautiful trick because here I have length of vector plus 1 entries. So the fact that this one is never included itself, that makes the total included numbers to be exactly equal to what? Length of vector. So that's a beautiful thing to have, okay? So you see, yes, you can include the last number here. So this is one of the methods of for loop that we use the range method. Start number, end number, and the step size. So I will take over those numbers and then you repeat some task. Another method for loop that you can do is to say for values inside this vector. So this time you're not going by index, you're going by value. You say for any value in this, if that value mode 3 is 0, so if the number is a multiple of 3, go ahead and print that value, right? So look here, any number that is a multiple of 3 in this basically vector is basically printed for you. So you have what? You have 3, you have 9, you have 18, and then I assume that's it, right? There is a 45 because I just added 45, but I removed it as well, right? If I run it again, that 45 is not going to be there. So I ran it with the 45. So you see, it's only 3, 9, and 18. So you see here, I'm calling for any value. And you might say, is that a specific word? No. If you don't like it, call it for object, right? For object, for thing. For thing. And vec, if that thing, right, mode 3 is 0, ahead and print that thing. So make sure you change this one as well, and then go ahead and run it here. Look. You see here, no worries. So that val is not a specific thing, right? You can change it to anything you want. It just knows when you use the in operator, here I'm taking over values, not taking over indices. And this is exactly doing the job for me. So this is a what? This is a for loop. Here, I know that I have these many numbers, so if I go every other, then I will definitely get to end of it because I know how many. Python can calculate for me how many times it has to do this. Or when I have value in vec, it knows at most you have these many values that it has to go over, so that's it, right? Therefore, you know ahead of time because you're dealing with a finite size vector, and that's all you need. Now, sometimes you don't know ahead of time, like a while loop. For example, you want to keep asking the user to provide you with a positive integer number, and you return for the user the factorial. But you have to keep doing it until the user wants to play this game with you. So every time you're going to ask the user, hey, do you want to do it again? If they said yes, you keep asking for a number and you show the factorial. If the user says no, then you're going to stop the operation. So you have no idea when the user wants to enter yes or no, and so you have to use a while loop. So you see here, I'm saying, hey, this code is going to get a positive integer from you and returns a factorial. And then first I check with the user, hey, do you want to play? If it says yes, then I start the operation. If it says no, I'm not going to even do any while loop. So I say, while the answer is yes, go ahead and do it. Ask for the number, print the factorial, and then what? Go ahead and ask again. You see, go ahead and ask again. I did ask in the first place to start it, and then I have to keep asking so this answer can be updated. If I don't do that, and that's one of the mistakes that some students do make, they forget to add this part. They think because they ask one time in the beginning, that's it. No. You have to keep updating this variable. If you don't update it, and the first time I say yes, then it keeps going, right? And I'll show you that. Let me go ahead and play this for you, and then we'll see what happens if you don't do it. So here, you see, do you want to play the game? Yes. Give me a number, 5. 120 is factorial. Do you want to do it again? Yes. What is it? 7. 7 is 50, 40. Do you want to play again? No. And then it stops. You see, the cursor is back, everything is back, I'm done. Now, if I forget to do that, which is, as I said, a very, very common mistake, then you're going to have problems, right? So look here. Here we go. Do you want to play? Yes. What is it? 6. 720. Enter another one. I did 4, 24. Enter another one, 5, 120. You see, it never stops. It never asks you again, hey, do you want to do it again? It keeps just doing it. You give number, it gives factorial, and it keeps going forever. And this is called an infinite loop. You are basically stuck in an infinite loop until, excuse me, use Control C and you stop the infinite loop. So use Control C and break the loop like this. Okay, so make sure that you know this important thing, and I'll add that for you here. Use Control C to break an infinite loop, or any loop in general that you don't want it to go. Maybe some operation is taking too much time because you wrote a code that is inefficient. So you want to optimize the code and run it faster instead of waiting 2 hours for the code to give you some results. You want to do a job that gives you in maybe 20 minutes. So you can break out of the code and go back. And since I'm at the loop, let me give you one more example. So since I'm in for loop, let's talk about the nested for loops, which is a for loop within another for loop. And let's say you want to show me some times table, right? So if you want to print timetable, then you need a nested for loop, because you have two numbers, II and JJ, and each one of them is changing separately, independently. So you say for II, and then in a range, and you want to start at 1 and end up at 10. So you say from 1 to 11, right? Because you know always it's this number minus 1 that is going to be the last number, and the step is 1, so you don't need to show it. That's the default step. And then for JJ in range, again 1 to 11, then go ahead and print what? You can say II times JJ equals, and then this is II times JJ, and then some space, and then dot format, and then II and JJ and II times JJ, right? Now, if I go ahead and do this, what do you think would happen? Well, before that, let me comment out the rest of the code. So we just deal with this times table, right? So it is going to give me a times table, but is that going to write it like a table, like a square? Well, what's your guess? Probably not, huh? It's going to write it all below each other, because we learned that the print command, whenever it writes something, it is going to go to what? To the next line. So you have to be what? Very careful here that it is going to write everything below each other. But what did you learn in basic IO that you can continue? Do you remember? It was like something like this, and equals that. This will what? Will allow the next command to be printed after this instead of going to the next line. So if I do it this way, what would happen? Look at this now. Is that what we wanted? Well, guess what? The answer is no. Because look here, it does all the numbers from 1 to 10, but then it still continue. So I have to have a method of when it reaches the end of one for loop for one I, it stops this end, and then what? Allows the cursor to go to the next line. So if I go ahead and do an extra print like this, would that do the job? Because these two are both under the JJ loop, right? Would that do the job for me? Well, let's take a look here. No again, because every time I get what? I get this print. So for every JJ and for every II, it is going to what? For every JJ number, it is going to do that. What if I change my indentation and brings it just here? What does this mean? When I change my indentation from here to here, what does that mean? It means now this print command is not going to be done for every JJ, it's going to be done for every II. Because the indentation of this is the same as this for loop, and that's for an II. So it means set I to a number, go ahead and perform this whole for loop and continue on the same line. When you are done with the for loop, go to the next line and then start a new I. So just look what a simple change in indentation does here. Look. Right? That's what we wanted. You see? So that's another example that you see a simple change in indentation of this print command gives me a big change, and this is exactly what I want. So this is an example of a nested for loop for you. If you were wondering if I give you an example of a nested for loop, I did that for you. So hopefully this is useful for you, and I will see you in the next lecture. Thank you.